All right, ladies and gentlemen, let's get into covalent bonding and Lewis structures and how we can represent molecules. Okay, as a reminder, as the literacy connection stuff says, covalent bonds are formed between not metals. Now, that means nonmetals and metalloids. So if you're looking at your periodic table, as I drag this over so that I can look more closely at my periodic table, the nonmetals are basically to the right of this line. So you're talking about these guys right here. Those are your nonmetals. And then the metalloids are the ones that are next to the line. So these guys right here are your metalloids. Okay, so any bonding between those two groups, that would be considered covalent bonding. Now, so covalent bonds are formed between not metals when valence electrons, and that's important, are shared, again, important, to form a noble gas configuration. Now, the noble gases are here in group 8A, right? Noble gas configuration for valence electrons for these guys means that they have 8 valence electrons in their outside shell. The only exception to that is helium, which only has 2 valence electrons. So that means that all of the elements should have 8 in their outside shell. That's called the octet rule. And the only exception to that is hydrogen, because hydrogen will only gain that 1 electron or share that 1 electron to have 2 valence electrons in its outside shell. And we'll see that inside the Lewis structures themselves. When the bonds are formed, all of the atoms except hydrogen will have an octet, 8 electrons. Hydrogen will only have 2 valence electrons. Now, if you're doing a Lewis structure for oxygen or for anything, you need to be able to use your periodic table. So, first thing you need to be able to do is figure out what the valence electrons are. Now, we've covered that before, but your valence electron numbers are given by that group number. And so 3A, 4A, 5A, 6A, 7A, right? So those are your valence electron numbers. Now, since we're only dealing with nonmetals and metalloids, it's mainly going to be those that we're dealing with the exception, of course, of hydrogen, because hydrogen is, of course, a nonmetal. So, if I'm looking for water, then I am going to be looking at hydrogen, which has 1 valence electron, and oxygen, which has 6 valence electrons. And so when I do my Lewis structure, I'm going to have 1 valence electron here and 1 there, and then I'm going to have 1, 2, 3, 4, 5, 6 for the oxygen. Now, when covalent bonds are formed, remember, they are shared. So this single electron will share with that single electron to form a bond, and that single electron will share with that single electron to form a bond. And so in the end, what we'll have is 2 single bonds, which is 1 pair of electrons. And then we will still have the 4 electrons in the form of 2 lone pairs. a lone pair of electrons. Now, these guys, as it showed in your literacy connection, these guys are your bonding electrons. And these lone pairs are your non-bonding electrons. Now, whenever you're going to draw a Lewis structure, you're going to need to count up the valence electrons. So, the first thing you need to do is determine what atoms you have. So for CO2, I've got carbon and I've got 2 oxygens. So carbon is going to have 4 valence electrons. Oxygen is going to have 6 valence electrons. I'm going to go ahead and count those up. The key is to know the total valence electrons, okay? That's the big key. So 4 electrons there, valence electrons, then 2 oxygens times 6 valence electrons. 2 times 6 is 12, plus 4, 16 valence electrons total. I don't have to worry about whether it's an anion or a cation, positive or negative. I'll do that later. Next thing I do is I connect the atom with single bonds. If there is only one of an element, it is probably in the middle. There's only one carbon, therefore carbon goes in the middle. That means an oxygen on either side, and I have connected them with single bonds. Now at this point, I have 2, 4 valence electrons shown, but I need 16 total. Okay, so I'm going to need to add 12 more. The next thing that you do is you add pairs of electrons in a systematic way. Remember that hydrogen can never have more than 2. Doesn't really matter because we have no hydrogens. Now, it's difficult to explain all the little details in writing, but I can tell you that what systematic really means is this. These guys right here, excuse me, we consider these to be terminal atoms. In other words, they're at the end, right? And the easiest thing to do is to start on either terminal atom and fill them in such a way that you get 8, okay? So, if I start here, 2, actually, let me go ahead and count them total. That was 2, that was 4, that was 6, 8, 10, 12, 14, 16. Now you see what I've done is I have filled up the one I started with, and then I just continued on around, right? So I started here and I went counterclockwise and I just went all the way around, all right? And the key really to make it easy on yourself is to fill up that first terminal atom. All right, then we check the octet rule. If anything has less than 8, use the Robin Hood rule. Steal from the rich, give to the poor. All right, this guy has 8, that is fine. This guy has 2, 4, 6. That is not fine. So what I'm going to do is I am going to erase that pair, and I'm going to use it to make another bond. Actually, I'll go ahead and leave that thick because that shows me that that's a bond that I got from taking electrons away from this oxygen. Okay, now, what about carbon? 2, 4, 6, 8. Well, that's cool. But what about oxygen? 2, 4, 6. Not cool. Now I need to use the Robin Hood rule, steal from the rich, give to the poor. So I'm going to steal those 2 because carbon is rich, and I'm going to give it to a lone pair, to a bond. Now, does everything have 8? 2, 4, 6, 8. Great. What about carbon? 2, 4, 6, 8. Also great. Oxygen? 2, 4, 6, 8. Great. Now, do I have the right total number? 16, right? 2, 4, 6, 8, 10, 12, 14, 16. 16 valence electrons. This is a good structure. All right, now, example number 2. Things that contain hydrogen. All right, so we've got nitrogen and hydrogen. So nitrogen is here, 5 valence electrons. Hydrogen is here, 1 valence electron. So count them up. I have 1 nitrogen, N, so that's 5 valence electrons. I have 3 hydrogens, each of which has 1 valence electron. 5 plus 3 is 8 valence electrons total. Remember, you connect them with a single bond. Anything that only has 1 should go in the center. So, nitrogen, hydrogen, hydrogen, hydrogen. I will never have hydrogens connected to each other because hydrogen can never have more than 2 electrons, and it has 2 electrons right there. Then I count up my electrons. So here we go. 2, 4, 6. Well, I need 2 more, right? So I add pairs. Now, I could try to do this, but I cannot do that because hydrogen can never have more than 2. Hydrogen will only ever have 1 single bond. Okay, so I can't do that. The only other place that I can put these electrons is there. Now, do I have an octet? 2, 4, 6, 8. That's great. Do I have the right total number? 8, 8. That is great. This is a good structure for ammonia. Now, ions are a little different. You have to take into account the negative charge. And remember, from up here, if it is an anion, a negative charge, you add electrons, because remember, electrons are negatively charged. If it is, excuse me, if it is a cation, you subtract, because electrons, again, are negatively charged. So here we go. We've got a nitrogen and we've got oxygen. So nitrogen has 5 valence electrons, oxygen has 6. So nitrogen, 5 valence electrons. Oxygen, 3 of them. Each of them has 6. A negative charge means that I add an electron. 5 plus 3 times 6, which is 18, is 23, plus 1 is 24. 24 valence electrons total. If you have only 1 of something, you put it in the center. Nitrogen, oxygen, 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 and you connect them with single bonds. I have 2, 4, 6 electrons right now. I need 24. All right? So I'm going to start at a terminal, an end atom, and I'm going to add electrons to it until it's full, and then I'm going to move around the structure. Okay? So I'm going to start here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, I started here and I went around the structure systematically, counterclockwise. Clockwise doesn't matter. As long as you go around the structure, it'll work. Now I check them. That one has 8. 2, 4, 6, 8. That's great. this one right here, 2, 4, 6, 8. So that's great. This one here, 2, 4, 6, 8. So that's great. Leaves me with nitrogen, 2, 4, 6. Not great. Robin Hood rule, steal from the rich, give to the poor. It does not matter which one of those you steal from. Nobody cares. They are all absolutely equal. So I'm going to take this one and I'm going to use it to create that double bond. Then I'm going to do my octet check. Here, 2, 4, 6, 8. Good. 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 Total of 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Good. All right? And that is how you do Lewis structures for covalent compounds and polyatomic ions.